So the structures of ionic solids. A lot of these have crystalline structures that are very closely related to those unit cells that we looked at. But it's a little more complicated because we don't just have a single kind of atom. We have two different ions. And we have charges. And so we have to, if you've got a +1 and a -1, you have to have an equal number of the cations and anions, or you might have a 1-to-2 ratio. And that's going to affect how these things can squeeze together. So we have to balance coordination number. Higher coordination number is going to be lower in energy. Charge neutrality and different ion sizes. Or if one is really big and one's really small, that's going to affect how they fit together. I'm going to show you these, but I'm not going to quiz you on these or test you on these. So if we have an ionic solid where the ions are similar in size, so here we have cesium chloride, there's a cesium ion, and here's chloride ions. So this would be the unit cell, and again, only 1/8 of each of these guys on the corner is in the cell, right? So there's one cesium ion and a total, with all the pieces, of one chloride ion. And so we're looking at one of the ions as identifying the structure. So this is that simple cubic unit cell. You might say, well, why isn't that face-centered? Body-centered, because there's one in the middle. When you identify the type of unit cell, you can only look at one kind of ion. So we can choose to look at the green ones or the purple ones. Here we're going to look at the green ones because they didn't give us enough purple ones. But we're just going to look at the green ones. And the other one is just going to be fitting in where it can. If we have different ion sizes, then it looks a little bit different. So an example is sodium chloride. Sodium ions are very small and chloride ions are much bigger. If we didn't have to deal with charge neutrality, we could pack these in a lot closer, right? But we have to have the sodium atoms between the chloride ions. We can't have sodium ions next to each other because they're going to repel each other. So this is the structure, and again, this is a little hard to look at. What are we talking about here? So I'm just looking at the green ones, right? So the cubic unit cell, here's one face, and here's another face, and there's the top face. And what is in the middle of that? There's an atom, an ion in the middle, on the face. So that's a face-centered cubic unit cell with the sodium ions in between. It's called the rock salt structure. If we have an even larger difference in size, then we'll see things like this happen. This is called the zinc blend structure. So here we have sulfur ions forming a face-centered cubic unit cell. And then the zinc ions, instead of the zinc ion being here directly between these, they're going to fit into these tetrahedral holes in the middle. If you have a 1-to-2 cation to anion ratio, a lot of these will be a fluorite structure. So here the calcium ions are at the corners, and again, we've got that face-centered unit cell with the other ions being in between. You can also have an anti-fluorite structure if instead of 2 anions, you've got 2 cations to 1 anion. Again, you don't need to know those names.